Hello and welcome to another video brought to you by RouTube. In this video, I will be conducting a full regression analysis with many of the skills being taught and learnt across both Year 11 and Year 12 General Maths. So in this video, it's quite extensive in its information because full regression analysis obviously requires many steps. So like I said, there are a fair bit of information and obviously a fair few learning objectives upcoming in this video. So the first one is to construct a scatter plot with the use of the CAS calculator. Second one is to describe the association between the two variables. The third one is to interpret the coefficient of determination. The fourth one is to determine the regression equation in terms of the variables under investigation. The fifth one is interpreting the slope and intercept in terms of the two variables under investigation. The sixth one is to use the regression equation to make predictions. And the final one is to obtain a residual plot and use it to comment on the appropriateness of assuming that the two variables are linearly associated. So there is a fair few learning objectives clearly, because like I said, there are many steps to performing or conducting a full regression analysis. Okay, so this is the data in which we are going to conduct our full regression analysis. So we can just have a read here. So below are the heights and weights of a team of 16 hockey players, which allows their weight to be predicted from their height. So that's really important, the way in which the question is, or the statement is sort of worded. So it allows their weight to be predicted from their height, which therefore makes our weight as our RV, our response variable, and our height, or the player's height, as the explanatory variable going on our x-axis. So it says here, use the data to assist you in answering the questions throughout the video. So we're going to use this set of data and make our way through our full regression analysis. Okay, so the question wants us to create a scatter plot using the CAS. Now, just in the interest of time and not making you sit there and watch me enter the data values. I've already entered the data values in there in terms of the height and the weight of those 16 hockey players. Now, it's really important that you do double check that your data entries are obviously correct. So just sort of scanning through and just really making sure that all the values match up to the ones that you're provided with in the question. And it's also really important just to keep an eye on this, the number 16 in this case. It is really important because we should have 16 data values for height and 16 data values for weight, as we were given 16 data values in the question. So it's just a good sort of double checking that you haven't sort of counted any value twice or skipped any of the data values. So once we've entered it into our list and spreadsheet, we can then go ahead and get our CAS calculator to create our scatter plot for us. So there's a couple of different ways. You can either just press on or like I said, there's multiple different ways. So on, and then we're going to go to this pink data and stats page, and then you'll see all of your dots that are scattered all over the place. Now, essentially the most important thing is, and essentially the only thing that you really need to do from here is to make sure that you put your EV where your EV goes and your RV where your RV goes. If you put them in the wrong spot, I'll show you in a second, your scatter plot will look quite different. So click to add variable. Down here is your EV. Now, from the previous part of the video, we said that our EV was our height because our weight is going to be predicted. So when we do that, we can see our lovely dot plot has been created. And then as soon as we put our weight on our RV, we will see there we have a scatter plot that is created for us in terms of the scale and obviously all the dots. Now, there's plenty of things we can do with this scatter plot. We can obviously draw it from scratch if a question needs us to, if there's just got an empty graph and we need to draw it from scratch. Or if there were a couple of points missing, we can use our CAS to create the scatter plot like we have just done. And then you can obviously input the missing values as well. So there's plenty of different things you can do. And then as we're going to do throughout the video, we can sort of, find our residual plot and do a few other things in terms of finding the equation and things like that. But that's sort of coming up in the rest of the video. Now, one other important thing is if you hover over each point, it'll give you the coordinates. So to give you the x coordinate first, so that one there is 194 in terms of their height and 84 in their weight. And this one here, 199 and 98 as well. So it's really makes it a bit easier if you are needing to draw the graph from scratch. All right, so now what we need to do is we need to calculate the value of Pearson's correlation coefficient, which is the R value, to 2 decimal places, and describe the association between the two variables in terms of direction, form, and strength. And we're going to use the table in the top right-hand corner to assist us. Okay, so once we have obviously created our scatter plot, we need to go back to our lists and spreadsheets. So we need to go back here. And then what we can do is we need to perform a statistical calculation to find our R value. Okay, so we're going to hit menu and then statistics, stat calculation. And there's a couple of different ways we can do it in terms of finding our R value. I like to go with the linear regression, A plus BX way, but like I said, there's a couple of different ways. And then your X list is your EV, because that goes on your X axis, which is our height. And then your Y is our RV, which is our weight. And then as soon as you press that, when we scroll up, we should be given plenty of things in terms of our regression equation, which we'll get to in a little bit. But there we are in terms of our R value. Now, don't go with the R squared. The R squared is a coefficient of determination, which we'll get to in a second. So that value there is the one that we need to obviously write down and then round. So rounded to 2 decimal places, it should be 0.77, and it's a positive, which therefore means that the relationship between the two variables is a strong positive linear association, as the R value is between 0.75 and 0.99. Okay, so now we've had a go at the correlation coefficient. Let's have a go at the coefficient of determination. So as I said before, the coefficient of determination is the R squared value, which we can see, and we saw from the previous part of the video, once we perform our statistical calculation on our calculator, the R squared value also pops up, as well as the R value. So the question says here, determine the coefficient of determination to indicate the predictive power of this association. So there's a couple of different ways you can be asked to find the R squared value. But the predictive power, you sort of see it pop up from time to time. So if you do see the wording predictive power, don't freak out. It just means to find the R squared value. And then if you're ever asked to interpret, which we're going to do the second part of this little part of the video, it's always as a percentage. So yeah, the predictive power is always got to do with R squared, which is the coefficient of determination. And then it wants us to round your answer to 4 significant figures, which we'll have a bit of practice at sig figs again. And then the second part of the question, this should probably be a part A and a part B. And the second part of the question is then to interpret the coefficient of determination. So it's really important that you understand what you're being asked to do in the question. So whether you're asked to determine or find the coefficient of determination, or if you're asked to interpret the coefficient of determination, they are 2 different things. Now in this specific video, or this specific part of the video, we're actually challenged to do both. So if you're challenged or prompted to do one or the other, don't just do both. Don't answer more than the question sort of requires. But in this case, we're going to have a practice at not only finding the R value, rounding it, and then interpreting it. So I've just taken a little screenshot from the previous part of the video. So R squared, when you perform your statistical calculation, popped up as 0.598903. So what we need to do is, as the question says there, we are going to round to 4 significant figures. So clearly, there are a lot more than 4 significant figures there, more than 4 digits. But if you're not comfortable with your significant figures rounding, please practice that a lot, because it always pops up in SACs and definitely at the end of year for your exams, your VCAR exams. So please make sure you're aware of how to round using significant figures. So we have a look here, 0.598903. So when we're using, when we're rounding sig figs, we always start at the first non-zero. So the first non-zero, obviously working left to right, is 5. So 5 is going to be our first significant value or first significant figure. And then every value after that, every digit after that, every figure after that is going to be significant. So we've got 1, 2, 3, and then 4. So we're going to stop at the 9. And then after the 9, it essentially reverts back to how we would normally round a value. So essentially that value, which I will just highlight being yellow, that value there, 0, that determines what we do with the previous digit, the 9. So just like how we would normally round, if that 0 value was a 5 or above, that 9 would increase, or it was a 0 to a 4, that 9 would remain the same. So essentially we're just trying to chop off some values here so we don't have too many digits or too many figures here. So rounding to 4 significant figures, our R squared value is going to be 0.598903.
Now it'll stay at 5989 because, like I said before, that digit after the 9 is a 0, 5989. So that's our R squared value. So that's determining, that's the first part of the question. I'll just put a little tick there. That's determining the coefficient of determination, not interpreting. Okay, so that's sort of the first part of the question. I might just put a little one here. That's sort of the first part. Then the second part of the question is to interpret the coefficient of determination. So whenever you're asked to interpret the coefficient of determination, it's always going to be as a percentage. So you might want to just make a little note of that in your summary or your bound reference. It's always going to be as a percentage. And I'll pop this little template at the bottom for you that you can follow and put in your bound reference or in your summary, just so you've always got access to it. It's pretty much, like I said, it's a template for you to follow, and it never really changes with the interpretation of the coefficient of determination. There's pretty much just three things that change. It's the percentage, and then the two other gaps I've left there, which is your EV and your RV. So the template says the coefficient of determination the coefficient of determination indicates that, and then it's got a blank and a percentage. So we essentially, what we need to do is we need to convert our R squared value, which we found in the first part, into a percentage. Now we hopefully will know that, I'll just write down the R squared value, so 5989. To get that to a percentage, or to get any value to a percentage, we always just round it to 100. So you might have learnt just to move the decimal point 2 places. So essentially we're going to move it 2 places to the right to give us 59.89%. So now we have converted our R squared value into a percentage. So the coefficient of determination indicates that our first gap is going to be 59.89% of the variation. Now you'll see there's two gaps. So of the variation in something can be explained by the variation in something. Now the first blank is always going to be your RV. So what it's saying is the coefficient of determination indicates that 59.89% of the variation in weight can be explained by the variation in our height. So essentially, just make a little note, this gap here is always going to be your EV, and this gap here is always going to be your RV. Now, one final thing on the percentage, please don't just round. We always see, and always see in examiner reports, and even Saxon exams I mark, some students just round for the sake of rounding, but please don't just round that value to 60 if you want to round to the nearest whole number. Don't round it unnecessarily. Just go with whatever the question is asking for. If there's no rounding prompt, then just don't round. Okay, so essentially the template says the coefficient of determination indicates 59.89% of the variation in weight can be explained by the variation in height. Then that last sentence, the rest can be explained by other factors that can or cannot be included in there. It doesn't really matter. You're not going to lose any marks. You're not going to gain any extra marks. It's sometimes there, it's sometimes not. But the first two lines are what's most important there, not only to find the coefficient of determination, but most importantly to interpret it.
All right, now let's use our scatter plot to determine the equation of the least squares regression line that predicts players' weight from their height. Write your equation in terms of the variables with your coefficients rounded to 4 significant figures. So we'll talk about significant figures in a quick second. So once we have our scatter plot, as we can clearly see there, it should be very, very straightforward for you to find the regression equation. Now a common error that often gets made here is that students don't substitute or don't write the equation in terms of the variables used. So they use X and Y. But it's really important that you do substitute out for Y the RV word, so in this case it's weight, and then the EV for X, which is height. So if we're needing to find the regression equation from here, we just hit menu, option number 4, which is analyze, and then option number 6, which is regression, and we want it to show us in the A plus BX form, so option number 2, and there we are in terms of the regression equation. Now if you do need to move the regression equation, you can just hold down your little cursor onto the regression equation and you should be able to drag it up to sort of see it a bit clear or more clearly if you need to. Okay, now in terms of the rounding, so with significant figures, always start at the first non-zero. So with the y-intercept, negative 37.68 and so on, well, the first non-zeros are 3. So therefore, we should have our y-intercept rounded to negative 37.68. And the reason the 8 stays as it is because the next digit is a 4, which is obviously below 5. So negative 37.68 for our y-intercept. Now with our gradient or our b value, we've got positive 0.641114 and so on. Now we do start at the first non-zero. So the first non-zero is the 6. And then we want 3 additional digits after that. So we go 6, 4, 1, 1, and then we look at the third 1, and because the same idea as the y-intercept, as the third 1 is below 5, the previous one stays as it is. So that is why the regression equation is weight equals negative 37.68 plus 0.6411 times height.
Okay, so once we have determined the equation, we can do a couple of funky things like interpret the slope and the intercept in terms of the two variables under investigation. So, for example, in this case, we're investigating the weight and the height. So on the left-hand side, just like I did before, I've got a little template for you to follow in terms of the slope and the intercept, but we'll start with the slope. So the question says, interpret the slope of the regression equation in the context of the variables under investigation. And then I've just copied and pasted the regression equation that we obtained from the previous part of the video using the CAS. So we've got weight equals negative 37.68 plus 0.6411 times height. So everything that we're sort of going to be talking about now is all in reference to y equals a plus bx, where a is our y-intercept and b is our slope, which is our gradient. So essentially on the left-hand side, if we're referring to our slope, we need to know which value in our regression equation we're actually referring to. So our slope is that value there, and please take note of the addition sign that sort of comes before the slope value. So we're looking at a 0.6411 and it's a positive. That's really important there that we can identify that it's positive, and we'll talk about why that's important in a second when we get to our intercept interpretation. So the template for us to follow is the slope of the regression line predicts that on average, and then it's got blank blank. So essentially what we're going to talk about here is what the slope is actually telling us in terms of height and weight. So what we sort of need to indicate is what's actually happening. Is the height, is the weight increasing or decreasing, and what's it increasing and decreasing by? So what we're looking at here, the slope of the regression line predicts that on average, the weight, so it's the RV, in this case, it's the weight. And now the second gap after weight is if the gradient, because the gradient or the slope can be positive or negative. Now that's why I highlighted the positive sign before. So after weight, it's going to be increases. The weight increases. Now, if that was a negative value, so if the slope was negative, then where I wrote increases, it would be decreases. So the weight increases by, now we're going to list the B value, which is the slope value. So 0.6411 for every 1 unit increase in the height, which is our EV. So what I've got there, where I've got there 1 unit, that's really important. And every year students lose marks for not indicating that it's for every 1 unit increase. So just say for an increase, or they might say for every 10 increase, but it's really important when you're interpreting the slope, it's for every 1 unit increase, or in this case, for every 1 increase in height in centimeters. Okay, so just be specific with the type of sort of information you're given there. So again, use that template there. Weight is the RV, increases or decreases depending on if the slope value is a positive or negative. Obviously, the 0.6411 is just the value of the slope, and then for every 1 unit increase in the EV, which in this case is the height. Now we turn our attention to interpreting the intercept. So the intercept is just the y-intercept, and like I said before, when we're talking about y equals a plus bx, it's important that we know which value is the intercept and which value is the slope. So when we're referring to the intercept, it's this value here. So it's the negative 37.68, and just like I highlighted the positive 0.6411 slope value, it's really important that we understand that that intercept value of negative 37.68 is in fact a negative value. So our template says the y-intercept predicts that on average, the what is predicted to be what when what is at 0. So there's a few different blanks there for us to fill in. So the first one is the y-intercept predicts that on average, the whatever we're trying to find. So in this case, it's always going to be the RV once again. So the weight is predicted to be, because that's what we're predicting. The weight is sort of to the left-hand side of the equal sign. So that's our Y value. So that's our RV. So weight is predicted to be. Now predicted to be is simply just listing the intercept value. So 37.68, and make sure it's a negative when something is at 0. So that there is just going to be when our height is equal to 0. Now remember the first time you got introduced to the y-intercept, probably in year 8 or year 9, the y-intercept is always when x is equal to 0. So it's that moment where your regression line cuts through or intercepts your y-axis. So that's sort of what we're sort of speaking about here when we're interpreting the y-intercept. So the y-intercept predicts that on average, the weight is predicted to be negative 37.68 when height is at 0. Now, it's always important, it's also important to include units. So if we're talking about weight, in this case, it'll be kilograms, and in terms of height, it's in centimeters. But again, just be specific to the type of question that you are referring to. Now, in this case, just to finish off, weight is predicted to be negative 37.68. Now, clearly that's not possible. You can't have a negative weight in terms of, someone's height and weight. But again, it's just sort of getting familiar with interpreting the slope value and, in this case, the intercept value. So use those templates. Again, put them in your summary, put them in your reference, and make sure you have access to them when you are interpreting both the slope and the intercept. Okay, another thing we can do when we have our regression equation, like we just did, we obtained it from the CAS, is to make predictions. So this question here says, use the regression equation to predict the weight of a player who has a height of 183 centimeters and then round it to 2 decimal places. Then the second part of the question says, determine if the prediction would be interpolation or extrapolation and comment on the reliability of this prediction. So I'll leave interpolation and extrapolation for this moment, but we'll just focus on actually using the regression equation to essentially predict and come up with a value. So where I'm just going to highlight in yellow there, that's the regression equation we obtained from the calculator, and then rounding the values to 4 significant figures as we have done in the previous part of the video. The second step there, I'll just highlight it in yellow, is simply just a substitution step. So we're substituting the height of 183 in place for height, because that's the value we're given in the question. And again, I'll just highlight that yellow in the question. And then we can just use any calculator, whether it be scientific or CAS calculator, to obtain the answer. So essentially what this says is a player who has a height of 183 centimeters is predicted to have a weight of 79.64 kilograms. And again, that's rounded to 2 decimal places, as we can clearly see there. Then the second part of the question, like I said before, was all about interpolation and extrapolation. Now you need to have this in your bound reference, your summary. You need to have not only a definition, but an example of what interpolation and extrapolation looks like, and then understand what it means in terms of commenting on the reliability. So as you can see there, I've written there, as the prediction made was within the given data range of the explanatory variable values, which is interpolation. That's sort of the definition of interpolation. It is reliable. So what I mean by that is, if we have a look at all the data values in the scatter plot, this one I've just highlighted there, that's essentially the far right. That's the most right point. And then this one here is the most left point. So the most left point, if we're looking at the EV values, so the height, the leftmost point is at 178 and the rightmost point is at 199. So essentially what we're saying is, if the prediction is within these data values, anywhere within those data values, it's what we say is an interpolation. So it's a prediction that's made within the given data range. If the prediction is made outside of that data range, so in this case, greater than 199 or less than 178, that would be an example of extrapolation, which has a limited reliability. So in this case, as we can see there, the prediction we made was at 183. So it was roughly about here on the scatter plot. So that's clearly within our data range. So that is an example of interpolation, and therefore it is a fairly reliable prediction that we have made.
All right, now we can construct a residual plot and use it to comment on the appropriateness of assuming that the two variables are linearly associated. So from here, once we've got our scatter plot and we've done whatever we need to do in terms of the regression equation and the predictions, we can now press on menu, analyze, and then residuals, option number 7, and then we want to show a residual plot. And then you'll see another graph comes underneath the scatter plot. Now, essentially what those dots mean on the residual plot, all dots above the 0 indicate that they are positive residuals, which means that they are above the regression line. And any of those dots in the residual plot below this line of 0, any of the ones below, show that those values or those data values on the scatter plot are below the regression line, which we can clearly see in both. Okay, now in terms of making a comment on the appropriateness of assuming that the two variables are linearly associated, that just wants you to comment on the residual plot in terms of if there is a specific pattern or not. Okay, now in the residual plot, there is no pattern clearly shown. So what does that mean? So if there's no if there's no pattern in the residual plot, that indicates a linear association between the two variables in the scatter plot. So I'll say that again. If there's no pattern in the residual plot, which we don't have a pattern, there's no pattern there, there's no clear pattern, that indicates a linear association between the two variables, which in this case is height and weight. So once again, a valid answer here would be, as there is no clear pattern in the residual plot, this indicates that the two variables that are weight and height are linearly associated. Okay, and now just to finish off the video, often we are asked to sort of put the regression equation together into sort of a regression analysis report. So what I've done is I have created a template in which you can simply just follow these really simple and straightforward steps. So we need to use the following template, substituting in the RV or EV names for the red brackets. Okay, so wherever it says EV in this specific question, we're going to put the height, and then wherever it's got RV, the response variable, we're going to put weight because that was on our y-axis. Where it says units, we're going to use the corresponding units. So for example, if it's weight, we're going to put kilograms, and if it is height, we are going to put centimeters. So it's just obviously relevant to the specific question that we have. Everything else from there should be hopefully quite straightforward for you. But like I said, please follow this template in creating your report. It's essentially just putting the R value, the rule, the slope, the intercept interpretations, interpreting the R squared value, which is a coefficient of determination, and then finishing off with that comment about the residual plot and what it says and what it shows between the EV and the RV, the two variables. So like I said, there's your template. Please feel free to use it, obviously, to assist you in putting it all together in terms of the regression analysis. Thanks again for tuning in and watching another video brought to you by RouTube. As always, please feel free to like and subscribe, and I'll catch you next video.